Welcome to the College of Engineering. As one of 13 research-intensive colleges at the University of Saskatchewan, we're proud of the contributions we've made to our world and to our economy. Much of our success is the fruit of collaboration among the college's faculty and our industry partners. Every year, our college collaborates with about 45 industry partners to create and deliver quality education and research programs. These partnerships impact knowledge generation, student training, and benefits to industry.
This material came from a landfill in the United States, and you can see that it mostly looks like sand. It's got a little bit of debris in it. The question is, can this material be reused as engineered soil fill?
I'm a geotechnical engineer who works with wastes. As our cities become larger around the world, waste management is a huge issue. It's one of the four main functions of any municipal government, along with roads and water and sewer. As we move to a greater level of environmental protection, every hectare of landfill becomes more and more expensive to build. And so there's no reason why we shouldn't be building our landfills much steeper and much higher and taking advantage of the work that we've been doing with strength and compressibility of waste. So that would be, I guess, sustainable landfilling. The materials that are coming out of the landfill mining projects has a role to play in the whole notion of sustainable geotechnics. Let's use materials where we can rather than emptying our gravel pits, because gravel is a non-renewable resource. The work with methane, the cities in Saskatoon, they're in the process of building and commissioning a landfill gas to energy plant, and that in part built upon some of the work that we've done in our lab as well. So I guess everything's sort of a bit interrelated in terms of hopefully more efficient design, more sustainable long-term designs, and beneficial reuse.
I'm working on developing a robot to help farmers in the future. So I call it the robotic assistant farmer. There are several students helping me on that, and help farmer in simple tasks like spraying, particularly for precision seeding. Case New Holland is very interested in that one, and I have a collaborating research grant with the NSERC and the CNH on this project. One aspect of the job is navigation of the robot. So the robot can basically have very precise motion and put the seed in the soil. So the application of this particular project is directed toward the agriculture, but they can be used pretty much for anywhere. Like navigation of the robot can be used in mining. They can be used in outer space, that aspect of the project. Hopefully this project, when it's concluded, the other project would come along with that.
Well, masonry, as you know, is a very old building material. It's been around for thousands of years, and you know, a lot of the beautiful structures that we have are made of masonry, but lately the use of masonry has been declining somewhat. There hasn't been very much research in that material. There hasn't been a lot of innovation, and so there are other materials that are now becoming available which are cheaper to build and have some other advantages. So the industry then, recognizing these two kind of weaknesses, the Saskatchewan masonry contractors and suppliers donated $1.25 million to the College of Engineering to establish the Saskatchewan Centre for Masonry Design. There's three main objectives that we've got, and one is to educate engineers so that they know how to design with masonry and they're familiar with it and comfortable with it. The second one is to do research where we can develop innovative products and construction methods that will help make best use of masonry as a material. And then the third one is to educate the community on best practices in how to use masonry. There was a study done not so long ago which showed the impact of the masonry industry on the local economy, and of all the building materials, you know, you have to make the units, and you have lots of skilled workers that put it in place, and so it has a big impact on the local economy, and it's still a very important industry in Saskatchewan.
Unlike almost any other in the world, we are located on a university campus, being a national light source. That doesn't happen anywhere else. So we are very closely related and linked to graduate students, to colleague faculty, just a few hundred meters down the road. What we're doing is closely related, as far as processes are concerned, to microelectronics. Almost all other microfabrication processes that are based on silicon, we are completely independent of it. We work with polymers, we work with metals, and we just start to work with ceramics as well. So a whole different class of materials. Most people are concerned about the lateral size in micro and nanotechnology, but do it very shallow or planar architecture. We can do vertical architecture. We can be laterally small at the same time vertically high. And this is what separates us from almost any other technique. Industry funding is a major component, is a particularly large component in this facility. We have direct funding from global players like Rockwell Collins, for instance, invested into our laboratory when we started up. We also have got support from Saskatchewan Industry and Resources, for instance. Local companies like VCOM or Vesima, like SED, like research partnerships like TR Labs. And so we're tapping into that. Ultimately, we're talking about things that everybody can use. Next generation cell phones, communications, one of the research projects that also taps into the mechanical world with a local company, International Road Dynamics, was about monitoring what's going on the street wirelessly.
The University of Saskatchewan's College of Engineering is fertile ground for the creation of innovative solutions to some of society's most pressing challenges.